Hi everyone, my name is Yiming Zhou. I'm a PhD candidate from Jalali-Lab at UCLA. In the previous video, we introduced PhyCV, the first physics-inspired computer vision library, with its history, background, and highlights. As we mentioned in the previous video, currently PhyCV has two algorithms, PST and page. In this video, I will give you a demo of how to install the PhyCV library and use the algorithms in the library. First, I would like to point you to the official GitHub repo of PhyCV. The repo here has the source code, sample input images and results, test scripts, and a very detailed README file explaining the usage of the code. Okay, so let's start with the installation. For installation, the easiest way is to run installation from pip. So just simply type pip install PhyCV, then PhyCV and its dependencies will be installed. Here, I created a new environment called PhyCV demo, and we will install the library here. Okay, so the installation starts. It will take some time. So let's first look at the test scripts. Here we provide two test scripts as examples of running PhyCV. In the first test script, each algorithm can be used by simply calling the run method. Let's look at the code here. First, we import the library. Currently in PhyCV, you have page and PST, and both of them has CPU and GPU versions. Then we indicate the image that we are going to run algorithms on and the GPU device in a PyTorch fashion, because the GPU version is built on PyTorch. To run the CPU version of PST, we first instantiate the class, then we call the run method with all the required parameters. Finally, we can visualize the result. To run the GPU version, the steps are similar, except that we have to indicate the device when instantiating the class. Also, the return result is the torch tensor that locates on GPU, so we have to move it to CPU and convert to NumPy array for visualization. We can also run page algorithms, the CPU and GPU version, in a similar fashion. The only difference is the required parameters. You can refer to the README file for the explanation of the parameters. Okay, so this is the first test script. Then let's look at the second one. In the second test script, we show another way of using PhyCV. Here, each step in the algorithm is explicitly performed. If we look at the code, the first few lines are the same. Then again, let's look at the CPU version of PST. Instead of calling the run method, we call each step which follows the physical process sequentially. Load the image, initialize the kernel, and apply the kernel. Finally, the result will be saved as an attribute called PST output in this PST object. This is useful for real-time video processing where different frames needs to be loaded, but the same kernel can apply to all the frames. Under these circumstances, the init kernel can be called only once to save computation time. Similarly, the test script also provides the example of GPU version of PST as well as CPU and GPU version of page. You can try it out by yourself. Okay, so now the installation is done, and I've already downloaded the input images as well as the test scripts to this folder. So today we'll show the example of running PhyCV on this jet engine image as shown here. You can also try other images. We provide some examples in the GitHub repo. So to run the test script, just type Python test script in the terminal. After that, you will see the result of edge detection with and without orientation. So these two are the edge detection done by PST, both CPU and GPU version. And these two are the directional edge detection done by page, both CPU and GPU version. You can see the direction of the edge is encoded into the color of the output image. Note that the visualized results of CPU and GPU version may look slightly different because in the current release, the morphological operation in these two versions are implemented in using different image processing packages. What you can do is you can always turn off the morphological flag to 0 and add your customized post-processing at the end. So this is a result of running test script 1. So for test script 2, it will lead to the same results on a static image. So you can try it out by yourself. Okay, so this leads to the end of the demo of PhyCV installation examples. Thank you for your time. For more information, please refer to the GitHub repo, the Wikipedia page, and Jalali-Lab website. Thank you.